Hey guys, welcome back to Match for My Desk. Today I'll be answering question 2 from the AP Calculus BC FRQ. So let's go ahead and start. So this is a calculator active FRQ, by the way. So a particle moving along a curve in the xy plane has the position vector x of t, y of t at time t seconds, where x of t and y of t are measured in centimeters. It is known that the velocity x prime of t is at minus c squared, and the velocity y prime of t is negative c plus the square root of t raised to the power of 1 plus 2 plus 20. And at time t equals 2 seconds, the particle is at 0.36. So I think this is going to come in handy later in the problem. So we want to find the speed of the particle at time t equals 2 seconds, and we want to show the setup for our calculations. So we know that speed is the magnitude of the velocity vector, right? And we know the magnitude of the velocity vector from the Pythagorean theorem. That's going to be the square root of x prime of t squared plus y prime of t squared. And we want to evaluate that at t equals 2 seconds. So I would do this as my setup, and then all I would do is go ahead and plug that into my calculator, because this is a calculator active question. So I went in and plugged in the equations into my into my functions, so that it's easier to do the calculations with. So we have x prime of t squared plus y prime of t squared, and we want to evaluate this at t equals 2. So I'm going to get an answer here of 12.305. And it is not asking us to do units, so I think we should be fine with simply putting this. So I think if you put this, you would get full credits for this question, right? All right. So now we can move on to the next question. So we want to find the total distance traveled by the particle over this time interval here, and we're going to show the setup for our calculation. So distance is not a vector, it's a scalar quantity. So that means we're going to have to take the magnitude of something. So the way I would do this is, first I'm going to integrate from 0 to 2, and we're going to take the magnitude of the velocity vector, because we know that position is the integral of velocity, right? So if I integrate displacement is the integral of velocity. So if I integrate the magnitude of velocity, so the speed, I would be able to get the distance. So I integrate from 0 to 2 x prime of t squared plus y prime of t squared, and this should actually give me my answer. So if I plug that into my calculator, I should get an answer of, all right, hold on. So I'm supposed to integrate from 0 to 2 the square root of x prime of t squared, so y1 in my calculator, plus y2. And we're integrating with respect to time, obviously. So I'm getting an answer of 15.902. And we do not need units, so I think we should be fine with simply this. And my calculation in the calculator may be wrong, but I do get points, I think, for setting up the integral here. So now for part C, we want to find the y-coordinate of the position of the particle at time t equals 0, and we want to show the setup for our calculation. All right, so at time t equals 0. So we know the coordinate at time t equals 2, right? So y of 2 is equal to 6. So if I integrate from 0 to 2 y prime of t with respect to time, I should get y of 2 by fundamental theorem of calculus minus y of 0. And that gives me some value, right? And I know y of 2, so I get y of 2, let's call that x for now, right? Y of 2, this is just algebra problem, is equal to x plus y of 0. So we get with y of 2 is equal to x minus, first I need to set up that the integral is equal to some value x minus y of, so we want to find y of 0. Sorry here, I had some mistake. y of 2 minus x is equal to y of 0. That is if the integral is equal to x. So x is just some arbitrary value that I picked. And so if I integrate that, I will get an answer of, alright, so I'm integrating from 0 to 2. And then my calculator is going to be y2. I'm sorry here. I lost my entire calculations. Alright, great. So I need to rewrite everything. So let me just rewrite quickly. So we're integrating from 0 to 2. My prime of c dt is equal to y of 2 minus y of 0 is equal to, actually let me just put in straight up right now what it's equal to. This is equal to 7.174. So I get y of 2 is equal to 6, right? We show that here. Y of 2 is equal to 6. So I get 6 minus y of 0 is equal to 7.174. 6 is equal to y of 0 plus 7.174. And then from that, y of 0 is equal to 6 minus 7.174, which if I plug that into my calculator, I get an answer of y of 0 is equal to negative, sorry, I'm supposed to make this more clear, negative 1.174. And this right here is what I would put as my answer, and I feel pretty confident about it. So now doing problem B here. So for 2 is less than or equal to t is less than or equal to 8. The particle remains in the first quadrant, and we're going to find all times t in the interval. So 2 is less than or equal to t is less than or equal to 8 when the particle is moving towards the x-axis, and we want to give a reason for an answer. So if I map this out, we're in the first quadrant, so we're here, right? This is Q1, and we have a point. We're going to find all times t, so all times t, in which that point particle is moving towards the x-axis. So we want, alright, sorry about this. So I'm going to redraw the thing. So we want the velocity to be negative. So we want y prime of t to be, we want it to be negative. Yeah, we want y prime of t to be negative, right? Because if the velocity is negative, that would mean that it would be moving left. I think this should be correct, right? So if we set, honestly, I can just graph this, I think. So if I say that y prime of t has to be less than 0, I can input y prime of t into my calculator. I can go ahead and graph that, and I can find all values of x in which it's going to be negative on this interval right here, right? So the way I would go ahead and approach this is first graph it. I click on second trace. I want to find the 0 value, which I'm given as, hold on, I'm given the value at which, okay, I need to regraph here. So we're going to go from a certain value to another value. So I'm going to set up an interval. All right, so, okay, at t is equal to 5.2218333, this is when the graph is 0 and it's changing from positive to negative, right? So the interval I would set up is we're going from 5.222. So we're not including 5.222. But we are going to 8, right? Because 8 is negative. I think it is, right? Hold on, let me double check. Yeah, 8 is actually, yeah, I don't even need to double check. 8 is, so the graph goes something like this, right? So we're going something like this, and over here is 5.222, and 8 is somewhere over here, t equals 8. And so this right here would be what I would put on the exam if I was taking this specific form, and I would also maybe go ahead and put this. So thank you guys for watching this video.